So take a look at another examples in your slide. All is in your slide, page 58. Okay, this is a gate. Okay, but the water is at the back of the gate. So if the water is at the back of the gate, so the water will pull the gate. So this is your visual. Remember in my slide, this is your visual weight or visual volume by the gate. Okay, so problem asking you to calculate the resultant force act on the gate and also the locations, and the length of the gate is, the width of the gate is 2 meter. Okay, how to calculate? Okay, remember force, resultant force equal to square root force in horizontal square plus force in vertical square. So theta equal to arc tangent FV over F horizontal directions. So what is force in horizontal directions? So the solution is here. Force in horizontal direction means we imagine the gate is a, because the gate is under here, this one is not gate, this is a wall. So if you want to imagine the gate not until the surface, only here, because this is our gate only. So height not given, so you have to use the mathematical explain here. You have to use the mathematical problem, mathematical knowledge so to calculate the height of the gate after you projected as a plane surface. So the length is same 2 meters. So locate the CG, from CG to the surface is HG. So explain here. So after that we calculate force in horizontal directions. Okay, next is to calculate force in vertical directions. So this is a visual weight or volume. So you have to use your mathematical. So calculate area 1 is a rectangle plus another section 2. So you have to use the 30 degree of your circle minus area of the triangles, you get the area 2. So after you get area 1 plus area 2 times length 2 meter, so you get the volume of water displaced by the gate. After you get the volume, you can calculate the W by equation rho GV. So after that plug in into the FR and we get the theta. So this is your final answer. Okay, so I want you to do these examples. Let's try yourself. So it's a cylindrical gate, 4 meter diameter and 2 meter long, means 2 meter long. Contain water on both sides, water here and water also here. Compute the magnitude and direction of the resultant force exerted by the water on the gate. So first calculate force in horizontal directions, because we know FR equal to square root force in horizontal direction plus force in vertical direction square. So now we calculate F hash. So how to calculate F hash? So we have both sides of liquid. So now we calculate one by one. Force in horizontal AC and force in horizontal DC. So imagine, so the plate AC is flat plate, and curve DC is a flat height 2 meter, and then calculate force in horizontal direction. So flat, calculate force in horizontal direction. So flat, calculate force in horizontal direction. So at the end we calculate force in horizontal direction for whole system is force in horizontal direction AC minus force in horizontal direction DC. So how to calculate force in vertical direction? Same, because we get both system is force vertical direction upward, because remember this curve I explained already in the my lecture, and plus another quarter here. So force in vertical direction, upward. So how to calculate? At the end we can say that the semi ABC, volume displaced by semi ABC is equal to volume of half circle. So for curve DC, so the volume displaced is, because the water is up here, so this is volume displaced by curve DC. So if you want to calculate the volume, area times L, we got the volume. This is not F, this is V. This is not F, this is VDC. So how to calculate volume, force in vertical direction for DC? So therefore force vertical direction for DC, same here, equal to rho G V DC. So after that, the overall force in vertical direction is equal to force in vertical direction AC plus force in vertical direction DC, because both is upward. Okay, so after we get force in vertical direction, plug it into the equation and we can calculate where is the theta overall for the FV minus F horizontal. Okay.